This video is going to recap over the indice rules. Okay, there are a couple of rules which aren't on here, but you'll need to know those if you're doing higher tier GCSE. So this is enough for Foundation GCSE and Year 9 pupils. Okay, first thing we need to remember is that these laws only apply if the base number is the same. Okay, so the base number has to be the same. If they're different, we cannot use these rules. Okay, so in question 1, we've got a to the power of 7 times a squared. Now, if that was b squared, we would not be able to use law 1. Okay, because it's only for ones with the same base. There's no real working out to show. You just need to learn the law. Bases are the same, so all we do is add the indices. 7 plus 2 is 9. So that's a to the power of 9. Okay, have a go at question 2. Pause it, I'll give you the answer in a second. Okay, question 2. The base is the same, they're both p, but this time we've got 5 plus minus 3. So we're adding the indices, but we've got plus minus 3. That means we've got p to the power of 2. Don't forget, your negative number rules apply here as well. Okay, let's try the next one. Now the next one looks a little bit different. Question 3, we've got this 2 at the start. Now remember, 2a to the power of 5 is the same as 2 times a to the power of 5. So in this question, we just treat the numbers differently, because you've got a squared. Well, really, you could think of that as 1 times a squared. So in this question, we do it in 2 parts. First bit's to do the multiplication of the numbers which are there, the coefficients. So we've got 2 times the 1 from the a squared multiplied by a to the power of 5 times a squared. Okay, so we'll just do normal number work there. That's 2 multiplied by, use our indice rules here because the bases are the same. That's a to the power of 7. Well, we can shorten that. That's 2a to the power of 7. So you do it really in 2 parts. Do the numbers, the coefficients, then do the letters. Okay, I've got question 4. So press pause. I'll get the answer in just a second. I'll go through this one. Okay, right, in this one, we've got 4q to the power of 3. So that's 4 times q to the power of 3 multiplied by 2q to the power of 5. So if we move these things around, because they're all just being multiplied, we've got 4 times 2 multiplied by q to the power of 3 times q to the power of 5. Okay, that's going to be 8. Base is the same in these two, so we've got add the indices, law 1, so that's q to the power of 8. Okay, I've got question 5 and question 6. Press pause and I'll give you the answer in just a second. Okay, question 5, you've got the base is the same in both, it's a, so all you've got to do is add the 2 numbers, the 2 indices. Okay, so minus 4 plus minus 7 is minus 11, so a to the power of minus 11. In question 6, okay, the 5 times the 2 will get us 10. Base is the same, we've got 2 r's, so we've got r to the power of 3 times r to the power of 1. Okay, we won't normally write a 1. Add the indices, r to the power of 4. Watch out for that when you've just got r or x, any letter. Okay, let's try some more. Okay, have a go at question 7, 8, 9 and 10. I'll give you the answers in just a second. Okay, there's the answers to question 7, 8, 9 and 10. Question 7 is straightforward. Question 8, 3 times 3 times 3 gets you the 27. In question 9, 5 times 4 gets you the 20. Be careful, because you get 3, add, take away 5, so it's minus 2. In question 10, be really careful. Okay, there was a b squared in there, so we can't do anything with that. That's just there's a b squared on the end, and we can use the indice rules for the a to the power of 6 and a to the power of 2. Okay, question 11 sees us using law 2, the substitution one, or subtraction, sorry, not substitution. So this is if you've got the same base, remember, so we got d to the power of 7 divided by d to the power of 2, and we get this, we simply get d to the power of, take away the 2 indices, so 7 take away 2 is 5. In question 12, same thing, we've got the same base, so we've got d to the power of 5 divided by d to the power of 8. Base numbers are the same, so all we've got to do is take them away. So we get d to the power of 5 take away 8, which in this case is d to the power of minus 3. Done. Okay, you've got just question 13. Okay, and I'll talk to you about question 14 onwards in just a second. Press pause. Okay, let's answer question 13. Question 14, same idea, or problems we had before. We've got two coefficients. One thing, treat it as two separate questions. So in question 14, okay, you've got 15, we need to divide that by 5. We've also got a to the power of 9, and we're going to divide that by a to the power of 5. Okay, so we get 15 divided by 5 is 3. A to the power of 9 is supposed to be an a to the power of 5. When we divide those, we get a to the power of 4. Put our two answers back together. Right, 3a to the power of 4. Right. Have a go at the rest of those questions. Okay, remember, bases have to be the same, so watch out for that in question, the rest of the questions. Okay, here's the answers to the rest of the questions. Okay, in question 15, be careful, remember, there's a 1, that's h to the power of 1 there. In question 16, just do them as you see them. So 12, take away the 7 is 5, add the 3, cube to the power of 8. Right, let's try some harder ones. Okay, here's 3 slightly different questions. In question 19, we've got a fraction. But remember, as I keep telling you, a fraction is just a division sum. So in question 19, we've got 8a to the power of 4 times a to the power of 8, and we're dividing that by a to the power of 5. So we've got 8a to the power of 4 times a to the power of 8, and we're dividing all of that by a to the power of 5. So we can just use our indice rules. Okay, we don't need to worry about the coefficient. We've got 8a and then 4 plus the 8 is 12, take away the 5 is 7. In question 20, we get a slight problem. The problem is we have a coefficient on the bottom. We've got this 4 at the bottom. You need to treat this as two separate questions. Do the numbers, the coefficients. So you get 12 times 2, and we're going to then divide that by 4. 12 times 2 is 24. 24 divided by 4 is 6. So our coefficient on our final answer is going to be 6. Right, and then you do the a's. So you get a to the power of 3 times a to the power of 6, all divided by a to the power of minus 2. So that gets us, when we multiply them, all we've got to do is add the indices, so that's a to the power of 9, and we're dividing by, we've got a to the power of 9, let's write that, and we're dividing that by a to the minus 2. So we're taking away minus 2, taking away something bad, happening to someone bad is good. 9, add 2 is 11, so that's a to the power of 11. Question 21, we have a number in there, there are no letters, but we still use the laws as we see, as we know them. So this is an application of law 3, a negative, and a negative will create a reciprocal, a fraction. So 2 to the minus 2 will become 1 over 2 to the power of 2, and the negative disappears. We shouldn't really leave it like that. We know that 2 squared is 4, so let's write that. Find answer. Okay, let's try some more questions. Okay, have a go at these here. I'll give you the answers in a few minutes. Well, whenever you press play. Okay, there's the answers to those questions. Let's try a few more. Okay, last set of questions. Have a go at these. I'll give the answers in a few seconds. Okay, here's the answers. Question 31, 32, 33. Anything to the power of 0, doesn't matter what it is, always 1.